Hello everyone. So today I, Swati Verma, Assistant Professor at Kalgotia's University School of Medical and Allied Sciences, Department of Pharmacy, shall be discussing with you modes of vibration. In the last lecture we had discussed about the introduction to IR, what is the basic requirement to use IR spectroscopy, which particular compounds are IR active and which particular compounds are IR inactive. Moving forward, we will discuss about the modes of vibration. In the previous lecture, I have told you that in a particular IR, what is happening, your molecules are vibrating. Whenever they are present at your ground vibrational state, they will vibrate. Okay? Then in particular vibration, what will happen? Your molecules will undergo a change in the dipole moment. As they are vibrating, the dipole moment is changing. Now that particular change in the dipole moment will generate an electric field around itself. That particular electric field is having a certain frequency. Now whenever your incoming IR radiation interact with the particular molecule, your incoming IR radiation is also having certain frequency. Whenever there a match occurs between your incoming IR radiation to the frequency of your molecules at which they are vibrating, whenever a match occurs, your molecules from your zero vibrational level will move forward to your upper vibrational level, and in this case we can say that the absorption of radiation has occurred. So in case of IR we are getting an absorption spectrum as only vibrational and rotational changes are occurring. So the spectrum is known as vibrational rotational spectra. Moving forward, now we are having your fundamental modes of vibration. So the position of atoms in a molecule are not fixed and they are subject to a number of different vibrations. Vibrations fall into two main categories of stretching and bending. So we are having two fundamental modes of vibration, stretching vibration and bending vibration. Bond stretching change in the interatomic distance along your bond axis. Now your modes of stretching and bending. As its name indicates, in case of stretching, what is happening? We are stretching a particular molecule, and due to that particular stretching, what will happen? The bond length of your molecule will get changed. Whereas in case of bending, what is happening? We are bending a particular molecule, and as we are bending, its bond angle is changes. The simplest types of mode of vibrational motion in a molecule that are infrared active, those that give rise to absorptions, are the stretching and bending modes of vibration. So these are your stretching and bending modes of vibration, which are your fundamental modes of vibration. So this is a stretching, like in this your bond length get changes, and in case of bending what will happen, your bond angle get changes. Now in case of stretching vibration, what is happening? Further, your stretching vibration is divided into two: symmetric vibration and your asymmetric vibration. So we are having two types of stretching vibration: symmetric and asymmetric. In case of symmetric vibration, what will happen? You can see over here that we are having a center of loci. Now to this we are having two atoms attached. These two atoms will show a movement in the same direction. Like if it is moving in this particular direction, the other atom will also move in this particular direction. Like we can say that both the atoms will simultaneously reach towards the nucleus or will simultaneously recede away from the nucleus. Now in case of asymmetric vibration, what does happen? Your asymmetric vibration is just opposite to your stretching vibration, and in this case your atoms will show different movement. If one is going away from the nucleus, the other will come towards the nucleus. If this particular nucleus is coming towards the nucleus, now this particular atom will move away from the nucleus. So these will show the opposite movement. So in case of symmetric vibration, in which the nuclei simultaneously approach and then simultaneously recede from the center of mass on the bond axis. In case of asymmetric vibration, the angle between a vibrating bond and a chemical bond which is attached to one of the atoms involved in the vibration is not altered by a stretching vibration. It occurs when the nucleus moves towards a point while the other moves away from the point. So in case of stretching, both will show the same movement, whereas in asymmetric stretching, both will show the opposite movement. Now further, your bending vibration are categorized into two parts. First are your in plane and the second one is out of plane. Your in plane and out of plane bending vibration. Now further, your in plane bending vibrations are of two types, your scissoring and rocking. These are your two in-plane bending vibration, whereas your wagging and twisting are your out-of-plane bending vibration. So your bending vibrations are two types, in phase bending vibration and your out of phase bending vibration. In phase bending vibration is your scissoring, out of plane bending vibration is your rocking. Now further, what is happening in this particular vibration? In this particular vibration, your bond angle is changes. Bond length is not changing, your bond angle is changing. Like first we can see in case of scissoring. Scissoring is just like as your scissor works. So we are having here two particular atoms. These particular two atoms will simultaneously come towards the nucleus or will simultaneously move away from the nucleus. So both will show the movement in the same direction. Either they will come closer to the nucleus or they will move away from the center of loci. In case of rocking, what is happening? They are showing the opposite movement. If one is going like this, the other one will move like this. If this particular atom will come like this will move like this. So they will show an opposite movement in case of rocking. Now, what is happening in case of out of plane bending vibration? Out of plane bending vibration, and this vibration, what is happening? Your plane is changing. Like in case of wagging, both are showing the same movement. Either both are coming towards the nucleus or both are going away from the nucleus, but these particular molecules are showing, these particular atoms are showing movement in the different plane. Either both are going away from the plane, out of the plane, or both are coming towards the plane. In case of twisting vibration, what is happening? Both are showing the opposite movement and both are moving in the different planes. If one atom is going up like this in the positive plane, the other will go in the negative plane. Now these will show the opposite movement. This is your twisting. This is just like a monkey with a drum which we used to play in our childhood. That particular movement is shown by a twisting vibration. So we have stretching vibration and bending vibration, stretching symmetric, asymmetric, bending vibration, scissoring, rocking, wagging and twisting. For more details, you can refer to these particular references. Thank you so much.